Hello 8th grade, my name is Mr. Rogers and you're watching the video lecture for 3-1 on force in fluids. And to kind of change things up today, I decided to bring in a friend of mine, Mr. Arnold Schwarzenegger. Do you want to say hello?
How are you?
I'm fine. Are you doing okay today?
Yes.
Oh, that's good to hear. So, Arnold, we are talking about force in fluids, about fluid pressure. And our goals today are to define pressure and how it changes with depth. So, do you want to do the lecture or do you want me to do it? Do you want to do it, Arnold?
No deal.
Okay, I'll do it. Arnold, we'll come back to you. We'll see if you want to help out down the line. Does that sound good?
Yes.
Okay, so, Arnold, we'll come back to you later on.
Affirmative.
Okay, so, pressure, guys. Today we're talking about pressure and how pressure is exerted on different objects. So with pressure, pressure is equal to the force exerted on a surface divided by the total area over which the force is exerted. So what does that mean? Yeah, I don't know. Arnold, do you want to take care of this one for us here? What do you think?
No deal.
Okay. All right. So when you're measuring pressure, we're talking about a pascal of pressure. And Pascal is actually a ancient or middle-aged mathematician and scientist who did a lot of experiments with pressure. So we named the unit of pressure after him. So a pascal is a unit of pressure. So we measure the force to pressure on something, we're measuring it in pascals. And when you measure a pascal, it is equal to 1 Newton divided by a square meter. So 1 Newton divided by a square meter. So what in the world does that mean? We're talking about pressure. So what we want to look at here is a quick picture. And when we talk about pressure, it's over a certain area. So it's the amount of force being applied over a certain area. And I always like to think about common experiment like I just went horseshoeing. I recently just went snowshoeing with Mr. Rhines. And as this picture I'm going to post right now will show you. And when you're snowshoeing, the whole purpose of it is you wear those snowshoes, kind of look like tennis rackets, to increase your surface area, the amount of area that you're pushing down on the snow. So what you're doing is you're creating a bigger area. You have the same amount of force, but you have a bigger area that you're pushing on, so you kind of stay on top of the snow. You don't sink down into that 2 feet of snow we got out in our yard right now. So that's the idea of pressure, and a pascal of pressure is equal to 1 Newton of force, Newton of force pushing down, divided by that area. That square meter is the area. That'd be a pascal of pressure. So when we talk about fluid pressure, is going to be the focus of this unit and of this session. Fluid, we have to kind of define what a fluid is. So, Arnold, do you want to step in here?
No deal.
Okay, we'll come back to you in a little bit here, I guess then. So, a fluid is a substance that can easily flow like a gas or a liquid. Anything that can kind of flow, liquids, gases, anything that take up the space that they're enclosed in. So no matter what kind of bowl or cup or glass you put water in or liquid, it's going to take that shape. Gases will fill any space you give them. So anything that can kind of flow is the idea of a fluid. So when we talk about fluid pressure, we're going to go down to the molecular level, okay, the molecules. And if we could see them, we would see, especially like in gases, that they are bouncing around. All around the room right now, I can't see them, but there are air molecules bouncing off the walls, bouncing off the floor, off the ceiling, off of me, creating that fluid pressure on my skin, creating that air pressure on my skin. And that pressure is created by all those billions upon trillions of molecules bouncing off each other. And they kind of act as like one force, and they create that fluid pressure because they're acting together, acting as one, create that fluid pressure. So this is the same pressure you experience on a windy day. That's air pressure changing. Now in water, it'll be a little bit different. But we're talking about two last things here before we wrap it up. So we're talking about last two things here of the day. And so our last two things here. Arnold, are you sure you don't want to step in and kind of say a few things here? You know, I'd really like you to. I mean, you haven't really done much yet today. What do you say?
Stop whining.
Oh, I'm sorry. I didn't know I was whining. Jeez. All right, so I guess I will just talk about the last two ideas of the day. Our last two ideas of the day are how we talk about air pressure and how it changes. Well, air pressure decreases as elevation increases. So air pressure goes down the higher you get. You have to think about this like we're in a sea of air, and right now on the ground we're on the bottom of the ocean. So sea level would be the bottom of the ocean, and the higher you go, the more the air molecules are spread out. They're not as dense and compressed together. So there's less air pressure the higher you go. Or if you go mountain climbing, there's less air to breathe. It's harder to breathe as you go higher in the mountains because there's less air molecules for you to breathe in. Now on the other side of that, we have water pressure. How is water pressure created? Well, same idea. The deeper you go into water, the more that force of all the weight of all the molecules above you pushes down and creates more pressure. So the deeper you go, the more pressure you're going to have. You've probably experienced this before. Anytime you've been in the swimming pool and you go down the bottom and you got to kind of blow and balance out your ears, that pressure in your ears. So all that weight above you is pushing down, creating that pressure on your ear, and you kind of balance it by blowing a little bit of air out your nose. So the way we kind of look at this is we have two pictures here. And the way to think about it is here we have a few less molecules, and again, they're bouncing off the box. They're bouncing continually nonstop. You can't see, they're kind of keep bouncing, and they create pressure kind of working together. And if you put more, like the deeper you would go, you'd have more and more molecules compressed together, and so there would be more pressure. Okay, so 8th grade, we are going to stop here for the day, I believe. Arnold, do you have anything you want to say?
No.
You sure?
No.
Okay, do you want to say goodbye?
Hasta la vista, baby.
All right. Thank you, Arnold, for chiming in today, I guess. You really didn't do too much, but that's okay. So, 8th grade, I thank you for watching, and we'll stop there and see you along the way.